Now let me introduce our second keynote speakers for today. We have two speakers here, Abhishek Das, co-founder and VP Engineering at Acante, and Dhruv Jain, co-founder and Chief Product Officer at Acante. Both are very experienced and are going to tell us what is going on at Acante. You coming up? All right, so we've got this mic and we've got the other mic, so that's the clicker.
Perfect.
You go? Okay.
I'll bring him on.
Okay. All right.
Thank you. Okay.
Okay, so everyone, I should probably be using this. I guess for many of us as we grew up, this iconic HAL 9000 from Arthur Clarke's 2001 kind of epitomized for us what AI can be. The amazing things it can do, but also where things can go wrong. It's probably an understatement to say we are entering the age of AI. And aside from digital Doug, pretty much everything around us is going to be infused with AI in our personal lives, in our enterprise, professional lives, with almost every enterprise application, internal, external facing. Hello, everyone. My name is Dhruv. I am one of the co-founders and chief product officer at Acante, a data and AI security startup based out of Silicon Valley. And I'm excited today to talk to you about what role digital security, data security is going to play in this AI revolution that's coming up. So, despite the massive investments that we are seeing across enterprises in AI, almost 85% of the enterprises say we have got AI projects in motion. But despite that, less than a third of them are actually getting anywhere close to production. Right? There's clearly a gap between the possibility and the reality. And when you delve into some of the top pain points that they're seeing around productionalizing their AI applications, it turns out that the top ones are all things that require fundamental improvements in technology, external solutions, and not surprisingly, data security is among the top and actually increases in relevance as you go to companies that are above 500 employees or more. Right? Increasingly, companies are saying we need to use our data, just the way Doug talked about it, and use our data to use our competitive advantage as part of our AI applications. And over the last couple of years, you've seen a bunch of startups focus on model security issues, around some of the classic jailbreaking issues. But increasingly, companies are hitting against the fundamental security problems at their data layer. And these are the problems that Acante is focused on. To dig deeper into this, let me invite onto the mic Abhishek Das, my co-founder, head of engineering. He's been in the machine learning and AI space for a couple of decades now, from his days as a Stanford PhD, and then in the search space for a decade, including in the core search team at Google. So Abhishek, over to you.
Thank you, Dhruv. All right. So speaking about generative AI, right? Why are we all so excited about it? Natural language processing has been around for decades, but we are now in a new era. And we are in a new era primarily because in the last 5 years or 6 years, the large language models have come up. And they are basically built on top of, as most of you know, deep neural networks, right? Which allow you to train on massive amounts of data. What these models are capable of is they are actually able to figure out patterns and nuances of language. And the primary reason they are able to do that is because of the transformer architecture with self-attention mechanisms built in. What it boils down to is, instead of looking at text sequentially, we are able to actually look at text as a whole. We are able to figure out contexts in certain focus areas of the text and derive meanings out of it. And this is in a dimensional space which normally, if you're doing machine learning, you're not able to capture it, right? This is a really large vector space. But what is beautiful about the engineering is we are now able to actually embed this, represent them in a vector space using token embeddings, where things that are of similar context are placed closer to each other. So this notion of what is closer or similar to each other allows us to derive bigger meanings, right? The larger the context we have, the more reasoning we can do. The smaller the context it is, the less reasoning we can do. Okay, now I'm not going to talk, is this moving? Yeah, I'm not going to talk too much details about the models itself because this talk is not about large language models necessarily. But let's look at how they are being used, right? So foundational models are the basic models on which you're building your generative AI applications. It all starts with pre-trained foundational models. Now, think of it as like the Google Brain or the DeepMind, where companies who have large amounts of data, they have been throwing lots of resources, burning a lot of money, and building these large models. But they are also sellable. So think about maybe a self-driving technology. That's a pre-trained model that you can actually sell. That has then moved to these closed source models. Now, this is what really changed the game. Now you can use these inference APIs in your applications. So it became programmatic to be able to use the power of these large language models. However, there are a few things to note here. These models, their primary purpose is artificial general intelligence, or AGI. Okay? So they will hallucinate a lot because their whole motivation is they need to act smart. It's as simple as that. They don't have the domain context of your data or your specific vertical. They have no idea. They are meant to be a general intelligence layer. So they're fundamentally really good at reasoning, and hence they are very expensive to train. Not anybody and everybody can build them unless you have the resources. But that leads us to these open source models. These are relatively smaller models. They have a shorter context length as a result, but they can still reason really well. In fact, Lambda 3 just came out, Llama 3 just came out, and it's extremely powerful. But what's more powerful is that you can use these models and you can add another layer of training on top of that. That training will be on your specific data. And that can be a smaller data set. That makes these models more attuned to your needs instead of trying to be general intelligence, right? And I'm sure pretty soon people are going to build their own custom models, which will be smaller, relatively cheaper, but still NVIDIA's stock price is pretty much pegged on that they will be selling all these chips to build these models. So let's look at real use cases, right? How are people using this today? I think we heard about data monetization. We heard about recommendation systems like, for example, the Walmart Labs example. Those things become really easier now, right? You're probably building your customer service chat agents. That becomes easier. You can do knowledge-based Q&A for internal data. Those things become easier. You can also use it in different architectural patterns where instead of it being a single model being used for inference, you can actually use multiple models. You can take the output of one model, feed it into another one, and so on. You can even mix modals. You can do text and image together. You can do text and video together. And more use cases of those nature will evolve. And there is this notion of compound AI systems as well, where you can even create automated agents which are going to take action on their own based on inputs from other models. All right, but at the basis of all of this is really your proprietary data, right? I guess that's if I remember, the tagline is unleash the power of your data. That's the Data Summit tagline. So yes, so that's what you really want to do with your generative AI models. But you want it to be really controlled in terms of the guardrails that you put on these models. You want them to behave according to your needs. You don't want them to behave as per they want, as if It's a different artificial intelligent agent. You also want to make sure that your data remains private and confidential. You don't want to disclose all of them publicly. And at the same time, you want to maintain your competitive edge. So how are you people going to use this in their enterprises or in production applications? So I'm sure you have heard these terms before. So these are the three most popular mechanisms that people use. Prompt engineering, retrieval augmented generation, which is RAG, and fine-tuning. Prompt engineering basically means that you're going to use the model as is, but you're going to tell the model in terms of instructions or in terms of programmatic framework how to behave, right? You are going to give some kind of examples. So you'll say there's techniques like one-shot learning, two-shot, few-shot learnings. There are techniques of chain of thought where you give some you break it down into steps instead of just inferring the question as is. But this is the reason it's very popular is it's very cheap. You don't have to update the models at all. You don't have to update the model weights at all. But what that means is you're not able to create the full context of your specific domain. And that's where retrieval augmented generation comes in. It was actually introduced to control hallucination. Okay, so I want you to answer it in the specific context of this data. So you're providing it the context. Now, remember, the models, the larger the context, the better they are. But if you're using smaller models, you could really, even if you want to introduce a lot of context, you will not be able to. They're just fundamentally not able to capture that. However, again, there is no training needed, no model weight updates are needed, so that's why they're easier to use. And then that brings me to fine-tuning. Fine-tuning is you're essentially updating the model weights only at the last layer of the neural network, not all the layers. So it's relatively cheaper, but more importantly, you can actually throw your own data to it. And you want to say, my model should be trained on this very carefully selected data set. And that will govern the behavior of the application. In practice, it's actually a mix of all of this. I don't think there are probably a few use cases where you can only do RAG or you can only do fine-tuning. But in practice, and it will evolve, it's just a mix of all of these three things together. What a recent survey says is 75% of the organizations are actually already using a mix of RAG and fine-tuning together. And I will show you how you can do that. So let's look at the stack in terms of the application, right? The inference layer is, let's call it, that's the application layer. Below that, there is the model layer, which is powering the application. And even further below that is the data layer, which is powering the model itself. To represent it more visually, like I said, the application interface is at the very top, and there is some form of a query going into the model layer, and it's expecting some kind of a response back, right? Like I mentioned, in order to reason using these models, you would be, instead of using one single query engine or one single model, you'll be using some kind of a graph or some kind of a chain of these query engines. And once you get the response back, it builds the proper context for the language model. And that's what is called prompt engineering plus augmentation. So that's the augmented context. And now when you get the response back, before you actually give it back to the application, you may have to do some post-processing to make it suitable for your specific application. So this is at a very high level how your architecture will look like. But let's now go look deeper into the data layer. How does this really happen? So what I'm calling the query engines, where you use prompt engineering, let's say, to expand the query itself, or you rewrite the query itself to be more suitable to your models. They go and they basically first have to build the context using your unstructured data. And that's the retrievers using vector indexes. So these retrievers look at a new kind of databases today. It's the vector index databases. This is where your unstructured data, which has been chunked into smaller and smaller sizes, they have been embedded using the token embedding that I referred to earlier. And that allows you at runtime to look for your more specific data as context to the query. Now, the beautiful part here is that you can actually update this data as often as you want, because the model doesn't have to be changed at all. So you will always have the freshest context in mind. And that's just the unstructured data part. But then there are many analysts here. You already have feature engineered data sets that you use today in your applications. You can throw that too. In fact, you can also use the language model generated data as well. So you put all of these things together into some kind of a re-ranking feature where it looks at all of this context data, and based on that, it decides what's more appropriate for this specific use case, and then you run the language model on top of that. So finally, I would say the language model itself, you can use the closed source models, but more specifically, people are trying to use fine-tuned models. So you're training it on your own data set. And this has to be a very high-quality training data set, as you are all aware. So the key takeaway of all of this is that underlying all of this is your proprietary data. And that is what powers today's AI applications, and I would say even future AI applications. Now, when people talk about AI risks, I believe that it all starts from the bottom. It starts from your proprietary data, which is powering all of these applications. So at Acante, we have looked at this, and as you're aware, there are also regulations which are coming out, and some of them are already there regarding AI. And what we have done is we have actually mapped them to industry standard frameworks. A couple of them I will call out. One is OWASP LLM10. The other one is Databricks AI Security Framework. And I'm just going to show you a few of them, how it maps together. So number one is privacy and confidentiality. You may have your own compliance, for example. That's there. That starts at the very bottom layer. The other one is training data poisoning. If you're training on top of your high-quality data set itself, make sure that data does not have any malicious code or malicious data itself getting inserted. Then there is prompt manipulation. Remember, this augmentation is being done using your own data, so that itself needs to be protected. And then there is unauthorized access or access control. Specifically, vector databases have now come in, so you have to be careful about that. I'm going to speed through this a little bit. There is if you're using any third-party sources, and I'm pretty sure that's what many of you will be talking about, you have to make sure that that itself doesn't get manipulated by any means. So I hope I gave you an overview of some of the risks and how Acante is addressing them. Here are a few screenshots of access policies that you can build using Acante. Then we do data classification, where you can actually determine the sensitivity of different kinds of data. We also do expose when you violate any of these governance rules using the policies that I mentioned. We can even attribute it back to, hey, how exactly which data was used by which particular user for a specific use case. So these are all the powers that Acante is bringing into the technical stack that I just presented. With that, I will wrap up. If there is any questions, please contact Dhruv or myself. We will be at the booth outside.